So in this video, we're going to talk about Newton's first law and the idea of uniform motion and to help you conceptualize what it is. Okay, so the first law, Newton's first law, and I'm just going to paraphrase. It says that everybody persists in its state of rest or of moving with constant speed in a constant direction. Okay, except to the extent that it is compelled to change that state by forces acting on it. Okay, so what the hell did I just say? Basically, Newton's first law is saying an object, okay, an object's motion will not change. It will not change unless there is a net force acting on it. Okay, that's essentially what Newton's law is saying. And this brings us back to the idea of uniform motion. So when we talk about uniform motion, we have a couple of cases, but we're going to talk about two. Okay, and we say an object is in uniform motion when, okay, so an object is moving at a constant speed in a straight line. So we say an object is moving at a constant speed in a straight line. That's what we consider as uniform motion. Now, another case, and this is the special case, okay, is an object at rest. Is an object at rest. Okay, so maybe you could imagine I have a bicycle here and it's going with some sort of velocity down. It's going in the positive x direction. Okay, it's going in the positive x direction at a constant speed, and maybe we could say he's going at 5 meters per second. Okay, the constant velocity, he's moving in the same direction. He's experiencing forces, but they all cancel. Okay, so the person on the bicycle is experiencing forces, but they all cancel. If I put a circle around my object, and I define this to be my object, net force is actually zero. Okay, it's going in a straight line. There's no change in direction. That's what we consider as uniform motion. Now the other one is an object at rest. So maybe on a frictionless surface we have a block of mass. Okay, if I circle my block, it's at rest. Okay, is it experiencing multiple interactions? Yes, but they all add up to zero. So the block is not moving. So that's another case that we consider to be a special case of uniform of motion. So those are the two cases that we're going to focus on. Now, my question to you is, what if I have this question here? I'm going to ask you a question. So what if I have this object that's traveling and it's leaving a trace behind, and the traces are equally apart? Okay, so let's pretend that these are equally apart. Obviously, I can't draw the scale, but these are equally apart. Okay, so these are equally apart, and these are the traces that the object is leaving. So equally apart. And what if I say B, we have the object and the trace at one point is here, the other one is right under there. The next point is spaced out, the next point is spaced out. Okay, these are the traces for B. And then we have another object, it's moving in a circle, okay? So these are the traces it's leaving. Okay. And D, I have an object that's moving at a constant speed in a circle. Okay. My question to you is, which object did not interact with another object somewhere? Is it A, B, C, or D? Well, we gotta think about the idea of uniform motion. It did not interact with an object, which means that somewhere else. It's Newton's first law. We're thinking about Newton's first law here. So if I'm looking at B, okay, I see that at some point my object sped up and it slowed down, right? Because my traces are changing. So that means that has to have some sort of force acting upon it. If I look at C, I'm not moving at a constant speed. That's number one. So that brings it out of the way. Okay. And number two, well, if you look at it, at some point, my velocity is going up, right? So at some point I'm going up, okay? And at this arbitrary point, I'm going down. Well, what does that tell me? I have a change in direction, okay? So that means that I have to have some sort of interaction. Now, what about D, okay? Well, again, I'm moving at a constant speed, but again, at some point, I'm moving in this direction. At some point, arbitrary point, I'm moving down. So I'm changing direction again. There has to be some sort of force. So the only answer that left is A, okay? And we could say this did not interact with an object somewhere else. And why? Well, we're moving at a constant speed and we're moving in a straight line. Notice there's no change of direction. So that's what we consider as uniform motion. And we could use Newton's first law to kind of picture what we're really saying here.